for chapter number 2, and you can see this in your PowerPoint notes that the percentage mean 1 part per 100. So I can see that there is 5%. Okay. Also, the 1 part per 1,000, it is 5 per mil. 5 per mil. But of course, the percentage, you'll see it a lot in environmental engineering abbreviation. And also the part per million, which what I discussed in the class, that it is 1 part, let's say 1 part per or divided by million parts. This is ppm, part per million. Part per billion, it's 1 part per 10 to the 9. 1 part per 10 to the 9 part. It is part per billion. Part per trillion, it's 1 over 10 to the 12. So this is also one way of doing units in environmental engineering: ppm, ppb, and ppt. And of course, percentage is also one way of representing the concentration of chemicals, in sludge, heavy metals. And you will see this a lot in the examples once we get into sludge, concentration of organics in sludge. Also in this one, remember, if you see milligram per kilogram, and that's going to be the concentration of the organic in soil. Let's say we took a 1 kilogram sediment from Kuwait Bay. So 1 kilogram sediment, okay? And you took it to the lab and you measure, for example, benzene in this sediment, and you find out that there is 5 milligram benzene. Okay? So you took 1 kilogram sediment from Kuwait Bay, okay? And you took it to the lab and you told the engineer I need to know what is the concentration of benzene in this 1 kilogram sediment. So you find out it's 5 milligram benzene in this 1 kilogram sediment. So how could you represent this concentration? You just divide 5 milligram over 1 kilogram, and this is 5 milligram of benzene over kilogram of sediment. This is one way of representing the units in environmental engineering. Of course, there is other unit, ppm by mass, is also one way of representing the concentration of that organic or that chemical in sediment or in soil. For water and air, we use milligram per liter. Milligram of organic, milligram of pollutant per liter of water. Let's see that we took 1 liter of seawater. So you brought 1 liter, okay? And we took it to the lab, and I told the engineer, this is, by the way, this is soil, and this is water, or seawater, or liquid. And I told the engineer, tell me how many milligrams of benzene inside this 1 liter. She told me that there is 5 milligram of benzene. Okay, of benzene in 1 liter. So we do it like this: 5 milligram per liter of benzene. 5 milligram of benzene per liter of seawater or water. This is, you can do it for water, and you can do it also for air. You took 1 liter of air and you analyze the filter. After you filter the 1 liter of air, you find out that there is 5 milligram of benzene. So it's 5 milligram divided by 1 liter of air. The last one here, sometimes we use volume fraction. we divide the volume of the chemical over the total volume. Volume of benzene over the total volume of air. That's only for air. And we call this part per million, and you can see volume here. And of course, in water, we know this from chemistry, mole per liter, which is like molarity, and we use this only for water. We don't use this for air. We don't use this for soil, only for water. So try to understand this table because it's an important table for quiz number 3. One important example that is used everywhere, let's look at this fish. And we want to analyze mercury inside the fish tissue, inside the fish itself. So we have a fish, and we go and check the regulation of U.S. Food and Drug Administration. We could find out that from the regulation of the U.S. Food and Drug Administration, mercury in fish should be equal to, should not be equal to or higher than 0.5 ppm mass. And this is for wet fish flesh. So 0.5, it should not be equal. It should not be greater than. So 0.49 milligram, this is fish, 0.5 ppm by mass for wet fish flesh. Not dry fish, it has to be wet, just came from the water. Okay? If it's 0.49, there is no violation. If it's 0.48, there is no violation. If it's 0.5 ppm mass, it is a violation. So you will have too much mercury in your system, and that is not good for human health. Let's look at this example. If a channel, catfish, from a lake weighing 6 kilograms, so the weight of the fish is 6 kilograms. So this is, remember that we did find out before that if you want to find ppm, mass initial over mass total times 10 to the 6. So this is the total mass of the fish. This is, remember he told you, it's wet weight, which is like the wet fish flesh. And this 6 kilograms, you take it to the lab and you find out that there is 32 milligram of mercury in it. What is the mercury concentration in part per million by mass? So the mass initial of the organic is 32. The 32 what? You should put milligram. And what is the total mass of that species? It is the fish, 6 kilograms. This is the total mass of the species, the fish. Let's convert milligram into milligram or kilogram over kilograms, up to you. So I will convert 6 kilogram over gram, that's 1,000. So kilogram with kilogram, and then I will change gram to milligram, and 1 gram is equal to 1,000. So right now the answer would be 32 divided by 6. You can see here 1,000 times 10 to the minus 6. This is what? Milligram of mercury over milligram of fish. Yani for every milligram of fish, you're going to get that much of mercury in it. You should use a calculator and you will find that this is the answer. Okay? So later on, you want to find ppm. So you multiply this, since this is milligram of milligram or kilogram of kilogram or gram per gram, whatever, the units on top of each other has to be the same units. You multiply this times 10 to the 6. Remember 10 to the 6 here? So 10 to the 6 goes with 10 to the minus 6. You will end up with 32 over 6 ppm. This is equal to 5.3 part per million So 5.3 ppm mass is much, much greater than 0.5 ppm for the regulation. This is the law. It should be not equal to 0.5, and it should not be equal or greater than 0.5 ppm. 5.5 is much, much greater. And you should advise not to eat this fish because of the concentration of mercury inside the fish tissue is 5.3 ppm by mass, which is much, much greater than the regulation itself. Okay? So, we'll go ahead and finish the last example in the video number 2, which is the same thing, that you have 1 liter of water. 1 liter of water is analyzed and found to contain 5 milligram of TCE. So now we have milligram and we have liter. Remember the second part of the table? The second part of the table here, we did find this one, milligram per liter for water. So we have milligram and you have 1 liter. You took 1 liter sample and you found out that this 1 liter sample has 5 milligram trichloroethylene. Okay? So you divide 5 milligram over 1 liter. So 5 milligram over liter, and that is the first one, 5 milligram TCE over 1 liter H2O, because that was found in the water. And he need to find out the concentration of TCE in part per million by mass. So that is equal 5 milligram per liter. In water, this is only condition that happened only in water, only. Not soil, not air. So if you find milligram per liter, this is automatically equal to 5 ppm. Only for water. So this is going to be in quiz number 3. I will give you the concentration of TCE in water, and I'll ask you what is the concentration of ppm. You don't have to do any calculation. 5 milligram per liter of trichloroethylene is equal to 5 ppm by mass. Okay? There's no change, only for water. For air, it will change. For soil, it will change. Milligram per liter of air to ppm mass. If you just want to go ahead and find out the actual by doing the calculation, that's going to be really time consuming. You don't have to do this, but we'll do it now. 5 milligram per liter TCE over 1 liter of water. And you know that 1 liter of water is equal to 1,000 grams. If you measure in a mass balanced 1 liter of water, you will get automatically 1 kilogram of H2O. Okay? So by this, you cancel out liter with liter. Yeah, now you'll end up milligram per gram. And you have to convert the gram to milligram or the milligram to milligram, whatever way of doing that. Let's say gram. One is 1,000. So gram with gram. Liter. You end up right now with milligram over milligram. So let's look at that. 5 times 1 over 10 to the 6. So it is milligram over milligram. And of course, remember, to find ppm, you have to multiply it by 10 to the 6. So this with this, you'll end up with the concentration is 5 part per million of mass. Okay? And of course, to have 5 milligram per liter of TCE, it's beyond the limit of the allowable U.S. drinking water distribution standards. You could see here, if the U.S. drinking water standard for trichloroethylene is 5 microgram per liter, or 5 part per billion. You found 5 part per million. So, of course, it's not advisable to drink this water because it is much, much greater than the allowable concentration of trichloroethylene in water. And of course, this is a very dangerous, and you have to set this up to protect human health. And I think that's it for this example, and hopefully you'll be ready for quiz number 3.